Right, grade 11s, let's look at a fascinating principle that we call completing the square. Okay, this has got such a lot of applications. You'll see in analytical geometry, it's a wonderful little section, and often grade 11s battle with this, but it's actually not so bad. Completing the square, you need it for analytical, you need it for calculus, and you can solve various equations using this technique. But before we even go there, let's have a look what we consider a square, or what we call a perfect square. For example, if you take the number 4, we call this guy a perfect square because it can be written as 2 times 2, and the square root of 4 is 2. So if you can square root 4 nicely, 4 is called a perfect square. If you take, for example, if we look at another one like 1, can be written as 1 times 1, and what is the square root of 1? Is 1. So 1's a perfect square. You can do so many. If you think of 9, for example, 9, the square root of 9 is 3. It's a perfect square. The square root of 36 is 6. Remember, it's always positive. And that's a perfect square. 36 is a perfect square. And 25 can be written as 5 multiplied by 5. The square root of 25 is, of course, 5. So 25 is a perfect square. But what is also interesting is you can relate this to algebra. For example, if I look at an expression x plus 2 all squared, what is that? Well, x plus 2 is a perfect square because, look, it's written as x plus 2, x plus 2. Those are identical brackets. They multiply together. So that's a perfect square. The square root of this is also that. So this is called a perfect square algebraic expression, if you like. In fact, it's called a quadratic expression because if you look at something like this, have a look here. If I take what I've just mentioned quadratic expression. Remember, quadratic in grade 11 is got to do with x squared. So remember that funny word quadratic is called, you did this in grade 10, but quadratic is where you've got an x squared. So anything with a squared, x squared, is a quadratic. Okay, it's almost in the graphs of grade 10, if you remember, it's a parabola, but don't worry about that. A quadratic expression is x squared. In fact, it's something x squared plus something x. That's what a quadratic expression is. Okay, quadratic. Okay, now, if you look at this, if we factorize this using grade 10, well, we've got, if you look at the previous parts, we had an x and x. The signs must be the same in plus, and 1, because check it, x squared, 1x is 2x, and 1 times 1. So this is earlier work. But notice, this is a perfect square trinomial. Trinomial, this is what we call quadratic or trinomial, three-termed expression. Okay, it's a quadratic trinomial. So these are what we call trinomials, three-term things. And it's perfect square because you can factorize it as two identical brackets. Let's look at another perfect square trinomial. If you had x squared minus 6x plus 9, well, the signs must be the same. If you remember, and the minus tells us they must be the same. X and x. Now look at this, 3 and 3. X squared plus 9. And this is a perfect square trinomial, which is x minus 3 all squared. Remember, check it. X times x is x squared. Then the last terms would be positive 9. And then you've got negative 3x. Minus 3x is negative 6x. Okay, but again, it's a perfect square trinomial. Let's try one more. Here's a perfect square quadratic trinomial. How's that sound? Quadratic for the x squared and trinomial, three terms. Okay, so here we factorize this. And there we go. Into two identical brackets. Look at this. X plus 4, which of course is x plus 4 all squared. And you can check it by multiplying out. Okay. Okay, now what I want to show you is absolutely mind-blowing. People, you're going to absolutely love this. And I want you to watch this. If I take a perfect square quadratic expression, which is the x squared thing there, x squared, quadratic, trinomial, three terms, so it's a quadratic expression, or quadratic trinomial, there's a massive principle, a beautiful principle that relates. So we're not completing the square yet, we're developing this. Now watch this. I want you to focus on the coefficient of x, the middle term 2, the coefficient of x, which is 2. But I want you to look at this 1, and this is something so beautiful. 1 can be expressed as, now watch this, 1 can be expressed as a half of, now if you look at that, of 1 squared, or half of 2 squared. Now look at this. If you think of this carefully, I want you to see something. Do you notice that that 2 belongs there? A half of 2 and you square is actually, a half of 2 is 1, which happens to be that term there. So what, I want you to watch that again. It's so important. Let's just do that again. If I take x squared plus 2x plus 1, this last term connects to the middle term here, the coefficient of the x, as follows. If you look at this, if I write x squared, so let's summarize this 2x. If I rewrite 1 as a half, okay, now watch this, it's a half squared. Whatever this guy is there, the coefficient of x, if I put him into here, there he is, I put him in there. Half the coefficient of x squared, this is still, think about it, is still 1, because a half of 2 is 1, and 1 squared is 1. So there's no change. Do you see that there? So there's a wonderful connection. What they're saying is that in a perfect square trinomial, the last term is half the coefficient of x all squared. We're going to do a lot more of these to just clarify this. Okay, now hold on to this. If we look at another perfect square trinomial, what about x squared minus 6x plus 9? Now we know that that's, we've worked that out as x minus 3 squared. We know it's a perfect square trinomial. But watch the connection. Have a look here. I'm saying that if you go like this, the coefficient of x is minus 6. Now look at this. And what I'm saying is that if you go half the coefficient of the middle term x and square, look what happens. This, a half of negative 6 is negative 3, and if you square it, that gives you the last term. Is that not amazing? And it only works for perfect square trinomials. So this is a perfect square. So if we look at another one, let's have a look here. If you've got x squared, this is a perfect square trinomial. We worked with this previously. What are the factors of this thing? Well, we know it is actually x plus 4 squared. We've worked with that. Okay, we factorized that, okay, before. But now watch this. The beautiful thing is if you take x squared plus, what is the coefficient of x? It's 8. The last term is 16. Okay. If I go and write, now watch this, a half the coefficient of x squared. The coefficient here. Look what happens. It's brilliant. You haven't really changed anything because look at this. This is going to be a half of 8 is 4 squared. And guess what? That is actually the same as 16. Which is precisely our perfect square. So there's a huge connection here. And what it's saying in general, that when you've got a little trinomial, whatever it is, it can be x squared, let's go plus bx plus whatever, c. The last term c is really this, and this is important, people. It's a half the coefficient of x all squared. That's where b goes in there. And this is going to be a very, very important thing for completing the square. You're going to see exactly what it's all about in a moment. But what I want you to master is the fact of that middle term in relation to the last term is the c, the last term, is half the coefficient of the x squared. Now hold on to that, and it only works with perfect square trinomials. Okay, guys, now let's look at what all of this is about. Okay, if you take, I want you to look at this expression quickly here. Now, what I want to do is if you look at it, it's a two-termed expression. if I want this to be a perfect square, trinomial, I must add something in. Okay, now to do that, what I know is with a perfect square is that the last term is a half the coefficient of the x. Okay, so that's important. Now, remember, we started with x squared minus 8. So this would give you a half the coefficient, which of course is negative 4 squared, which is 16. But do you agree with me that actually, if you have x squared minus 8x, it's a standalone thing. If you add 16 in there, that's not right. But if I subtract it, then I haven't changed that original term. So what if I add something and I must subtract it? And the important thing of adding half the coefficient of x to this as a last term, it means that this is a perfect square trinomial, which we've already dealt with. Look at that. Okay, it's a perfect square trinomial. So those would have cancelled, so it doesn't affect anything. So if you look at x squared minus 8x, if you add half the coefficient of the x and square it, you're making a perfect square trinomial. But you must subtract 16 so you don't affect the original. Okay, that's so important there. If we look at it again, so whatever it takes, I mean, if you had x squared minus 4x, if I want to make this a perfect square, well, I add in, let's make it plus to make it easier. You're adding in a half the coefficient of x all squared. But you're not allowed to do that because that originally was x squared plus 4x. So I must just simply then subtract, and then I'm cool. Then these cancel. But remember, half of 4 is 2. 2 squared is 4. So I'm adding in 4 and subtracting 4. So then x squared plus 4x plus 4 minus 4 is still x squared plus 4x, but you've added in the 4 and subtracted it. Now the beautiful thing about this is that this is a perfect square as you factorize, and you've got x plus 2 all squared minus 4. Now that is really the same as x squared plus 4x, because if you look at that, this is actually the same as this. And this version is called completing the square. Okay, if you look at it, x squared plus 4x plus 4 minus 4 cancels. So if we explore this a little bit further, let's have a look here. If I take another example, this is the one in the notes. If I want to complete the square on an expression like this, okay, what I want to do is I want to make this a perfect square trinomial by adding something in. So what I do is I go x squared minus 8x, and I add a half the coefficient of x all squared, but then I subtract it because I'm not allowed to just do that. Okay, and then of course the little 10, let's tag him on there. This 10 stays there. Okay, and then what do we have here? X squared minus 8x. A half the coefficient of x is a half of minus 8, which is going to be a half of negative 4 squared. Then we subtract the exact same thing, plus 10, and then we've got x squared minus 8x plus 16 minus 16 plus 10. And look, you haven't changed anything. That's still x squared minus 8x plus 10. The 16's cancel. But what the importance of the 16 is, now the half the coefficient of x all squared. This is a perfect square, which we've already dealt with. And then negative 16 minus 10 is negative 6. This is called completing the square on x squared minus 8x plus 10. Now, what I want you to do is try the practice example. We're going to do a lot more of these because once you get into the technique, it's easier. So here comes the practice example. Let's give it a go.